We could speed it up. Hey everyone, welcome back to part 2 of how to create a metronome on the Game Boy Advance. Now we're getting into the fun part of the video, which is actually making the metronome part. And for this, I recommend you check out the Audio Programmer's channel. He has a lot of videos on how to do things like this, and he actually has a video on how to make a metronome. This one will be a little bit different because we're working with an older device and not just a Juice plugin, so it will be a little bit different in a sense, but it's mostly the same concept. So if you want to go check those out, I recommend it. I watched all of them. So each measure in a Western music has a timing characteristic, which we sometimes call a time signature. And how you can figure out how many beats in a measure is the number on top will tell you exactly that, how many beats are in a measure. And then the number on bottom will tell you what value is the beat. Is it a quarter note? Is it an eighth note? And so 4/4, for example, would sound something like this. So in that piece of music you heard, the BPM, the tempo, what we've known as, is called the BPM, and that was 145 beats per minute. And so that tells us right there something important. What are the beats? We know from that example that the beats are measured in quarter notes. There's 4 of them in a measure, and the BPM, the beats, that pulse per minute, is 145. And so that right there, that is the magic into this, because what actually is beats per minute? Well, that's what it is. It's beats per minute, but we call it BPM sometimes just as an abbreviation. But that's what that really means, and that's valuable, because if we look at the Tonc Timers, Tonc, again, very helpful resource on this Game Boy Advance programming. Tonc tells us that the Game Boy Advance has 4 registers dedicated as timers, so we can use these registers to measure time. And the CPU of the Game Boy Advance ticks at 16.78 megahertz. Now, what the hell does that mean? Well, you can imagine if John Cena was punching a punching bag. If he was punching that bag at 16.78 megahertz, that means he'd be punching it 16.78 million times a second. Now that's a lot. Wow. What am I doing with my life? Okay. So that's a little bit of a weird number there, and it gives us a period of 59.59 nanoseconds. Very, very precise, but it is a little bit too small for us. So what can we do to get around that? What can we do to get a nicer value? Well, it turns out we can use something called a prescaler, which we can divide that frequency and make it into a beautiful frequency that we can use. And so it turns out, actually, if you divide, I think it's 16.77, which is roughly 16.78 megahertz. If you divide that by 1024, you get about this number, which is 16,384. And that's a really nice number, because if we look at each of these registers that keeps track of the time in the Game Boy Advance, those registers are 16 bits. So they can have 65,535 different possible values. And after that value, that means the register will reset. It will start counting at 0 again. And so if we take that number and we divide it by 4, we get roughly 16,384. And this is really nice, because this number right here in hexadecimal is 16,384. So if we go back to our code that we were working on in the last video, we can do some stuff now. We're going to start using the timers now. So what we can do is we can first set the initial value of timer 1, which is the timer we're going to use. We can set that value to -4,000 in hex. Now what the heck does that mean? Well, that means this value is going to be -16,384 below where the overflow is. So that's going to be roughly, I think I have it in the script here. This is going to be, it is 49,151. So this timer is now going to start at 49,151, and it's going to overflow each second, which means that we'll get an overflow each second, which is really nice because now we know how long a second is, okay? And we can do that all again by using that prescaler. So that's really helpful to us. And so once we set this control register of the timer to that 1024, that's going to give us that nice prescaler that's going to do all the work for us. And how do we actually keep track of the seconds? Because it's a little bit weird to just say, okay, here we have 449,151, that's our 0. Yeah, that's a little bit weird. So what we're going to do is inside our update metronome loop, we're going to first only call this when the register value is different from the second value. So we're going to say if this is not equal to the second value that we have up here, then we're going to set that value so it's the same, and we're going to subtract. Actually, let me fix this here. This is where you can fix your code, which is actually poorly written because I'm thinking that they wouldn't be equal in this case. Just ignore that. We're going to skip over that. We'll optimize this code later. But anyway, just pretend like they're not going to be equal every time. And we're going to set the seconds to whatever is in that register value, whatever the timer is keeping track of. And then we're going to subtract that initial value. So that way, when the timer is at 0, which is actually 49,151, then this seconds value will be at 0. And that's really cool. All right, so now that our metronome will actually keep track of the seconds, we're going to go ahead and define what happens at the start of every new second or every new beat. Well, when that second is equal to 1, then we know officially that a new beat has begun. And so what we're going to do is the beat, we're going to say if this beat is greater than 3, so the count minus 1, which the count is 4, then that means that we have actually passed our measure, our beats in a measure, because here we're indexing at 0, and that's a really important thing. So we're going to go ahead and reset our beats to indicate that a new measure has begun. And if our beat is already equal to 0, then we know that's the first beat in the measure. So we're going to make that a special one, and we're going to do this function boop here, which is going to make a beep sound. We'll write that later, but this one is going to do a G because that's special. It's the first beat, so we got to make it sound different. Otherwise, it's just a regular beat, and so we're going to do note C. And then, of course, we want to increment the beat as well to tell it, hey, we've done a beat now. And yeah, that's what we do on the start of every beat. Now, here's what we do when a beat is passed. So we know a beat has passed, let's say if we're in 4/4, when our second value is equal to whatever a quarter note equals. And we'll get to that in a second. So what we want to do is stop all the timers and reinitialize everything. And we want to say, hey, now we can enable this timer because we reset all the values. We know we've passed a beat now. And so that's what we do. So how do we actually calculate a quarter now? Well, what we can do is we can say quarter is equal to this. It's equal to our BPM times 983,040. Now, how the heck did I get that number? That's a really weird number. So what I did, it's all about that formula of the BPM times 60 times whatever you get in a second is your note value. And again, watching the Audio Programmer's channel will really help with this. I really like his Metronome series because it really gets to you what the BPM actually is, what it does. Because if we do 16,384, we know that's how much we get in a second. So that's going to tell us what our seconds are. And so we need to multiply that by 60 because that's our beats per minute, right? 60 seconds in a minute. And then we multiply by our BPM and we get ticks. We get the amount of ticks for that note value. And that's going to define that quarter note value. And finally, we want to add some initial text, the BPM, all of that. And next, we're going to add some key functions. So we want to be able to control our metronome. And so we can press start, the metronome is going to start, press it again, and it's going to stop, or it might be select, but we need the key pole to do that. So we're going to go ahead and put that in there, and here's our button input. So yes, if we hit the start button, we're going to start the metronome or stop it, and then if we hit the up key, we're going to increment our BPM and then update the text and the note value as well, because that will change. And then we'll do the opposite if we hit the down key. And finally, we need to call this back in our main function. So we're going to do init metro. That's going to call all of this stuff. And so here's what we got so far. We got all of this. We set our value. Oh, you know what we didn't do yet? We didn't do the boop function. And so all that's going to do is it's going to set the first tone register to play whatever frequency we define down here. All right, and so this is everything now. This is our metronome. It's crazy. We finally got it. So let's go ahead, just review. We're doing that boop. We set the timer values. We set everything we're going to track. And then here's all our metronome stuff. And there's our main stuff. So let's go ahead and do what we need to do to make this now. How the heck do we make this into a Game Boy program? So this is where watching my previous videos on Game Boy music will help. I'll link them down below. You're going to want to check those out because it's super helpful stuff on how to set up the tool chain for this. So what we want to do is go to the folder where our C program is, our C code. So I'm going to go ahead and go there. Should be in the Metro. All right, so here's the folder where that is. What you can do to open that in terminal is you can right click on it and select new terminal at folder. All right, so now we're in that folder. If we type ls, we can see there's our C file right there. And next you want to make sure that your compiler is set to so that make knows where your compiler is. Can't really make the file if you don't know where the compiler program is. So you want to do that command, and then make now can make our file. But it doesn't know how to make it because we don't have a make file, so we need to get that now. So what we're going to do for that is if you go to the Tonc introduction website, you can find a folder called toncode.zip. So go ahead and download that, and inside, if you go to the folders that I'm going to right here, you'll be able to find a make file. So go ahead, copy the timer demo make file, because this is the example I built off of to make a metronome. And so I'm just using this make file. And if you go ahead and go back into Metro, we can paste that. And then we're going to need to make some edits real quick. So the proj, I'm going to change to Metronome, because that's what our project is called. And then we need to also change this directory right here. And make sure you have those variables here that I'm using. So we want to make sure DevKit Pro actually exists, because otherwise the computer doesn't know where that is, and that's a problem. And then I think it might have been if you do libtonc. It's either libtonc or tonc-lib. I always forget it, but we'll find out here in a second. All right, let's try making it. So we just type make. And boom, no such file, so it is tonc-lib. All right. This is good make file practice. All right. Oh, no such file or directory. Okay, that's not good. Yeah, I'm pretty sure it's libtonc. All right, let's try it again. No such file or directory. All right, let's try our export. This one. Let's try make again. No such file or directory. Oh, you know what we need to do? There's also a font in here that I didn't end up using. So I think if we go down to here somewhere, we'll find the Burke. Where is Burke? Here we go. So we don't want to use this. We don't want to use that Burke font, so we're just going to go ahead and get rid of that and try making again. Oh, frick. No. Okay, let's try it again. Awesome, so that worked. So what I did is I just removed that Burke file because that was for a font that I wasn't going to end up using, so that's why I did that. All right, here's the moment of truth. Let's test out our metronome. So what I'm using is a program called OpenEmu, which I will leave that in the description so you can download it. But here we go. If we press the start button, which in this case is return, we could speed it up. I like it. But let's actually test, how do we know if this metronome is legit? Like, how do we know that that is actually the BPM we want? Well, we can use Ableton Live. So I'm going to go ahead and open up Ableton Live, and then I'm going to set my preferences so it outputs to the proper place. All right, that should be good. So now, yeah, you guys can hear that now. All right, so now I'm going to do, say, 159. I like to do some weird number so that way I can tell that it's actually working. All right, so let's make sure this is 159. All right, let's try it. Oh. There we go. So as you can see, it works. We just built a metronome. That's pretty crazy. I hope you guys enjoyed this one. If you did, make sure to leave a like and subscribe, and I will see you guys in the next one. Peace. All right, that's getting annoying now. Let's turn that off.